Good morning to all. Welcome back to chapter number 2, process management of operating system. So before going to discuss this chapter, let's look about the articles of this process management. The process concept, process control, interacting process, inter-process message, implementation issues of process, process scheduling, job scheduling, process synchronization, semaphore, principle of concurrency, types of scheduling. So let's look about the process. So first, what is process? Process in computing, a process is the instance of a computer program that is being executed by one or many threads. It contains the program code and its activity. Depending on the operating system, a process may be made up of multiple threads of execution and that execute instruction concurrently. That means a process is somewhat interchangeable with a task or a job. Process nothing is simply you can see in the layman language that is a job or it is a task for the system. The process has been given many definitions. For instance, a program in execution, you can say an asynchronous activity, and you can say the process is not the same. You can say it is a job or you can say it is a task, right? So next come to the what are the state of the process. That means what do you mean the state? State means when a process enter into a system or entered into the processor. So there are number of the states through which a processor go through that states. So each process having the 5 number of states. First is your new, next is your ready state, then running, then terminating, and last one waiting, right? So first come to the process state of the new. A program which is going to be picked up by the operating system into the main memory is called a new process. Or simply can say in the new state the process is being created. The process is being created. Next come to the ready state. Whenever a process is created, it has signed, the operating system picks the new process from the secondary memory and put all of them in the main memory. The processes which are ready for the execution and resides in the main memory are called ready state process. There can be many processes present in the ready state. Or you can simply, a process is said to be ready if it uses a CPU if one were available. A ready state process is runnable but temporarily stopped running to let another process run. That means the ready state is a waiting area. It will be in the process area, but it will be in the wait if one process is running within that processor. Next is your running state. One of the process from the ready state will be chosen by the operating system depending upon the scheduling algorithm. Hence, if we have only one CPU in our system, the number of running processes for a particular time will always be done. If we have n number of processes in the system, then we can have n processes running simultaneously. That is the running state. Right? Next come to the waiting state. If the process is present in the running state and there is some interruption is occur or any IO event is going to be occur. That means suppose a process is present in the running area and it needs some input for further processing. Right now, so in that case the operating system wait for a, or we can say wait for some time. Then after that, the process is written into the waiting area. Let's take an example. Suppose A plus B is a process, A plus B. When the A plus B is entered into the system, it needs some input. That means it definitely to assign a value against A and assign another value against B. So, suppose there is some delay to provide the input, and that time period is expand, then operating system is it will be the throw to the waiting area. Yeah. Next come to the what is waiting area. From the running state, a process can make the transition to the block or wait state depending upon the scheduling algorithm or the interesting behavior of the process. When a process waits for a certain resource to be assigned or for the input from the user, then the operating system moves this process to the block or wait state and assign the CPU to the other process. What I will discuss. Suppose a process placed in the running state and needs some input for further processing, and there is some delay to provide the input to that particular process. Then the operating system moves this process to the wait area or waiting area, right? And question that when the process is released from the waiting area. Now, when the process gets the input, it will never back into the running state. It will be back to the, again it moves towards the ready state. That means, suppose a process P is present here, and it after getting some input, getting some the data, then it will never back to the running state, because each process is coming from the running state to waiting state. But after getting the input, it never back to the running state, it again back to the ready state, or go forward to the ready state, then after that it move to the running state, right? So that is known as the waiting area. Next is your termination or execution area. Here termination means when a process finishes its execution and it comes in the termination, then it comes to the termination state. So termination state is nothing, it is a process where the process has finished the execution, and it will also be deleted, the process will be, right? That is will be fully executed from that state. So these are the 5 states of a process: new, ready, running. If there are any interrupted or is there any requirement for a process, then it move into the waiting area. Then last state is the termination. Next, what are the operations on the process? First is your creation. What are the operations? First, creation, creating a process, scheduling the process, execution, and killing the process. So first come to the creation of the process. Once the process is created, and it will be ready and come into the ready queue or main memory. Ready queue means main memory, and will be ready for the execution. That's the creation. Once the process is created, it will be ready and come into the ready queue or main memory area. Next is your scheduling. What is the scheduling? Out of the main process present in the ready queue, the operating system choose one process and start executing it. Selecting the process which is to be executed next is known as scheduling. What is the scheduling? Scheduling is nothing in the layman language. It is a, you can say, the scheduling means what? It makes a timetable, or it makes a, you can say it is the, it makes the timetable through which all the process move towards the processing area. Next is the execution. Once the process is scheduled for the execution, the processor starts executing it. Process may come to the block or wait state during the execution, And killing state, what do you mean the killing? Once the purpose of the process gets over, then the OS will kill the process. The PCB will be deleted and the process gets terminated by the operating system. That means once the job is finished and if the purpose of the process is over, then operating system kill the process. Clear? So this is all about for today's class. For next class, going to the about the for next article. Thank you.